Engineering and Technology. Today we will discuss three remaining indeterminate forms, that is 1 raised to infinite, infinite raised to 0 and finally 0 raised to 0. So I will make you understand these different forms with the help of example. So example number 1 is, we have to evaluate the limit, that is limit x tends to 0 cos x the whole raised to cot x, cos x the whole raised to cot x. Okay. Now if you will put x equals to 0 over here, it will become cosine of 0 and value of cosine of 0 is 1. And then after if you put down the value of x equals to 0 over here, so it will become cot 0 and cot 0 is infinite. So this is 1 raised to infinite form. Now we have to evaluate the limit of this function. So let y equals to limit x tends to 0 cosine of x the whole raised to cot x. Now to evaluate the limit of the function like this, what we have to do, first of all we have to take logarithm both sides. So taking logarithm both sides, we have logarithm of y, that is equals to limit x tends to 0 logarithm of cosine of x the whole raised to cot x. Now according to the property of logarithm, logarithm of x raised to n, answer is n log x, right? So this one will be cot x into logarithm of cos x. Now if you put down the value of x equals to 0 here and here, so if you put down the value of x equals to 0 here, so this one will become cosine of 0 and cosine of 0 is 1 and log 1 is 0 and cot 0 is infinite. So this is 0 into infinite form. Okay. Now limit x tends to 0, this logarithm of cosine of x will be as it is and cot x is nothing but 1 over tan x. Okay. Now this is 0 by 0 form. Now to evaluate the limit of this function, we will apply L'Hopital rule. So logarithm of y that is equals to limit x tends to 0. We have to find out the differentiation of the function in the numerator and denominator. Now derivative of logarithm of cos x, that is 1 over cos x, and in place of x we have cos x, so again we have to differentiate cos x and derivative of cos x, that is minus sin x divided by derivative of tan x, answer is sec square x. Now we have to simplify this result, so logarithm of y that is equals to limit x tends to 0, this is minus sin x by cos x and 1 over cos sec square x, answer is cos square x. So one time cos x will cancel out, so this is equals to limit x tends to 0 minus sin x into cos x. Now in the denominator there is no term, so we can directly put the value of x equals to 0 in this function. So value of sin 0, that is 0, and value of cos 0, that is 1. So 0 into 1, the result is 0. So logarithm of y, that is 0. So y equals to e raised to 0 and e raised to 0, that is nothing but 1. And y is limit x tends to 0 cosine of x the whole raised to cot x, and its answer is 1. Okay, now we will discuss second example. Second example is limit x tends to 0 cot x raised to sin x, cot x raised to sin x. Now if you will replace x by 0 here, you will find cot 0 and its value is infinite, and for sin 0 it is 0, so this is infinite raised to 0 form. Now suppose y equals to limit x tends to 0 cot x the whole raised to sin x. Taking logarithm both sides, we have logarithm of y equals to limit x tends to 0 logarithm of cot x the whole raised to sin x. Now according to the property of logarithm of x raised to n, the result is n log x. So it will become sin x into logarithm of cot x. Now if you will replace x by 0 over here, so sin 0 is 0 and cot 0 is infinite, and logarithm of infinite, answer is infinite, so this is 0 into infinite form. Now limit x tends to 0 logarithm of cot x divided by cosec x, because sin x is equals to 1 over cosec x. Now this is infinite by infinite form. Okay. Now to evaluate the limit of this function, we will use L'Hopital rule. So logarithm of y, that is equals to limit x tends to 0. Now derivative of logarithm of cot x, according to the formula of logarithm of x, answer is 1 over x. So it will be 1 over cot x. Now in place of x we have cot x, so again we will differentiate cot x, and derivative of cot x, that is minus cos x square x, okay, and divide by derivative of cosec x. Derivative of cosec x is minus cosec x into cot x. Now minus minus sign will cancel out, and cosec x one time will cancel out. So we have limit x tends to 0. This is cosec x, right? One time cosec x will be there. Then after cot x into cot x, so it will become cot square x. Okay. Now we will convert cosec x and cot x in terms of sine and cosine. So limit x tends to 0. Cosec x is 1 over sine x, and cot square x, that is cos square x over sine square x. Okay. So cosec x is 1 over sine x, and cot square x is cos square x over sine square x. So it will become sine square x over cos square x. Now sine x one time will cancel out. So we have limit x tends to 0 sin x divided by cos square x. Okay. Now if we replace x by 0, so in the denominator we will be having 1, which is a non-zero term. So directly we can put the value of x equals to 0. So sin 0 is 0 and divided by 1 square, answer is 0. So we have logarithm of y. Logarithm of y equals to 0. So y equals to e raised to 0, and e raised to 0 is 1. And y is limit x tends to 0 cot x the whole raised to sin x. So the answer of this problem is 1. Okay, now we will discuss example number 3, that is limit x tends to 0 sin x raised to 10x. Sin x raised to 10x. Now if you will replace 0 over here, so the value of sin 0 is 0 and value of tan 0 is 0, so this is 0 raised to 0 form. So suppose y equals to limit x tends to 0 sin x the whole raised to 10x. Now taking logarithm both sides, we have logarithm of y equals to limit x tends to 0. Now logarithm of sin x the whole raised to 10x. It will become 10x into logarithm of sin x. Now replacing x by 0, so value of tan 0, that is 0, and value of sin 0 is 0, and logarithm of 0, that is minus infinite, so this is 0 into infinite form. Now limit x tends to 0, logarithm of sin x, and tan x is 1 over cot x. Okay, now x 0, so it will become sin 0, and sin 0 is 0, and logarithm of 0 is minus infinite, and cot 0 is infinite, so this is infinite by infinite form. Now to solve the limit of this function, we will apply L'Hopital rule. So logarithm of y, that is equals to limit x tends to 0. Now derivative of logarithm of sin x, so that is 1 over sin x, and in place of x we have sin x, so again differentiating sin x, and derivative of sin x, that is cos x, and divided by derivative of cot x, that is minus cos x square x. So this is equals to limit x tends to 0, this is cos x by sin x, and this minus sign will be as it is, and 1 over cos x square x, answer is sin square x. Now one time sin x will cancel out, so we have limit x tends to 0 minus cos x into sin x. Now there is no term in the denominator, so directly we will put the value of x equals to 0. So it will become cos 0 into sin 0, and minus sign will be as it is. And cos 0 is 1 and sin 0 is 0, so the result is 0. So we have logarithm of y equals to 0, but we have to find out the value of y, and y, that is equals to e raised to 0, and e raised to 0, answer is 1. So the limit x tends to 0, sin x the whole raised to 10x, and its answer is 1. In this lecture, we have discussed 3 indeterminate forms. One was 1 raised to infinite, the second one was infinite raised to 0, and the third one was 0 raised to 0. Thank you for watching this video.